Probability can feel confusing when trapped on a worksheet. Students memorize definitions, but rarely grasp the relationship between numbers and chance until they roll a die, collect data, and see the results for themselves. That is why we use the chance you take. It is a low-prep activity designed to make the abstract concept of probability visible through a simple game. To get started, you only need a few physical items: printed copies of the game board, a single 6-sided die, a couple of pencils, and at least 2 players. Moving away from digital screens, put students face to face. They sit together, roll real dice, and eventually have to justify their calculations to the person sitting next to them. Looking at the game board, you see a simple grid. Each row corresponds to a die outcome, labeled 1 through 6 on the left. The objective is straightforward. Students try to mark the highest number of spaces on their board before the game ends. Every roll on the board creates a new data point. By the end of the session, students have generated a complete, unique data set for mathematical analysis. Set up the activity by seating players in a circle and place your single die right in the center of the table. On a turn, the active player simply rolls the die and identifies the resulting face value. If they roll a 4, they mark one empty box in the corresponding row for the 4 on their own personal game board. Once that mark is recorded, the player must pass the die to the person sitting on their left. Repeating this core loop allows students to watch real data physically grow right in front of them. Eventually, a player will roll a number for a row that they have already completely filled in. When an unusable roll happens, the player to their left can steal it, marking a space if they have room. If that player's row is full, the roll travels clockwise around the table until it finds someone who can use it. Note that stealing a roll does not change the turn order. The die always goes to whoever was originally supposed to roll next. Because any number can travel around the table, the steal mechanic keeps every student engaged, even when it isn't their turn. The game does not automatically stop when one student finishes a row or even their entire board. Instead, the end game is triggered exactly when a value is rolled that nobody at the table can use. Look at this state. If a 3 is rolled but every player already has a full row of 3s, that creates a collective block. At that exact moment, the game is over. Everyone stops and counts their marked spaces, and the highest count wins. Because the ending relies entirely on a random roll, it provides a natural transition into discussing the unpredictability of experimental data. This printed document includes a dedicated space at the bottom. Direct your students to use this area to pull the total results from the entire table. This illustrates theoretical probability, taking one favorable outcome divided by 6 possible outcomes, giving a baseline of 1/6. Now compare that to experimental probability derived from actual gameplay, like seeing 3s land 15 times out of 90 total rolls. Provide the class with math talk sentence starters, like, "I noticed this number came up more often," to help them articulate why their results varied. They will quickly realize that while theoretical probability helps predict long-term trends, experimental data captures the surprising nature of real-life chance. If you are working with younger students, you can modify the activity by using language like likely or unlikely before calculating any fractions. To extend the challenge for older classes, swap in a 10-sided die and ask students to convert their final fractions into decimals and percentages. No matter how you adapt the rules, the true value is the human interaction and the rich mathematical reasoning that happens.